We're finally at one of the most important concepts in any programming language, and that's variables. So before we talk about variables, I want to talk about some concepts that you definitely learn along the way in computer science. But these were really, really hammered into me once I became a professional software engineer, a full stack developer. This is when things kind of fell into place. I had a lot of mentors, a lot of higher ups, a lot of people I worked under that kind of guided me towards a lot of these principles. Now, we definitely learned these, in like a rudimentary fashion. We kind of learned the basics of it, but we're going to try to kind of keep these in mind throughout the class. So programming is all about all these concepts here. Not limited to these, but these are some of the big ones. So abstraction. Oh, got a typo there. Let me fix that. There we go. That's better. So that's simplifying complex systems by hiding unnecessary details. So variables are going to help us do that. Modularity, breaking down a program into smaller, manageable sections. Again, variables, especially when we get to functions, that's definitely going to help us make our code modular. Readability and maintainability. When we define variables, that's all about readability. When we name these variables, we're going to talk about conventions and like best practices. This is going to make your code more readable. Comments are important, but if you name your variables really well, then comments are almost not necessary. Something I learned on the job. Dry, do not repeat yourself. Don't repeat yourself in your code. So use references to existing code. We've already kind of talked about references a little bit. But yeah, with variables, we're going to be able to make references to existing code. So variables help us adhere to dry. Efficiency, writing code that is optimized in terms of performance. That's always important as well. Using variables, we can optimize memory depending on how we use those variables. So when manipulating data in Java, we use variables to adhere to these concepts. You don't have to remember these. You don't have to understand these just yet. These are things we're going to keep in mind throughout the entire course of the class. And hopefully by the end of the class, these are going to make a lot more sense. And hopefully will be like guiding principles when you're writing your code. So what is a variable exactly? You've probably seen those in math, right? Yeah, all of you have must have taken at least algebra class where we use variables to represent numbers, right? Relationships. We use them in equations. Well, it's not too different in programming. In programming, a variable is a named storage location that holds a value, which can be changed during the program's execution. So yeah, a variable is actually taking space on your computer. We'll talk about that in more detail along the way, not in this lesson, but in future lessons. So variables are containers that hold a value of a specific data type. We've already talked about the primitives, but they can also hold more complex data structures as well, right? You can assign an object, for example, to a variable. So they're placeholders in your computer's memory where you store data. Each variable in Java must have at least a type and a name when declared. So these are the minimums. What do I mean by declared? I might have used that word already and didn't really explain it. Well, declaration refers to the process of introducing a variable to a program, specifying its type and name. Doesn't have to be a variable, right? You can declare a function, for example, or some other identifier. But yeah, for now, we're just focusing on variables. So it's when you introduce a variable. That's what declaration means. So we say declare a variable. That's the proper terminology in programming. So when you assign a value during declaration, this is called initialization. So when you first name the variable, you declare the type, but you also assign it a value, then you are initializing it. So when the first time you get a value, that's initialization. Um, Sometimes you don't pass a value to it, then you're not going to be able to use that variable until you give it a value. Now, if you give a value after you declared the variable, after you named it and gave it its type, then this is called assignment. So this is when you change the value of the variable after declaration. So initialization is during declaration, assignment is afterwards. So you're not always stuck with the variable you initialize it to. In most cases, you can assign it to a new value. So why do we need variables? What are they for? Well, variables are essential in programming because they allow us to store, manipulate, and the big one, reuse data throughout a program. Remember, don't repeat yourself. Uh, efficiency, right? Using code that's optimized, using the same data over and over. And then hiding unnecessary details. So we're going to hide data behind the abstraction of a variable name. So yeah, all these things, right? Variables do all those programming concepts, those pillars that we're going to think of when we're writing our code. So without variables, we would have to repeatedly hard code values. What is hard coding? We'll talk about that in the next slide. So that would make our programs rigid and inefficient. So variables make our code dynamic, allowing our programs to adapt to different inputs. That's just like math. In math, we use equations. In programming, we don't call them equations, we call them algorithms. But in both, we use variables to generate outputs based on different inputs. The math equation for, I don't know, Pythagorean theorem, right? Based on different values of the sides of the triangle, right? The lengths of the sides, you can find the length of the third side. The y equals mx would be, right, the linear equation function. Based on different inputs of x, you can generate different outputs of y, right, and create a graph or a line. That's the same with programming. Programming, you can input different values for a variable. You can transform that variable through an algorithm, through some kind of process, through a series of steps. You transform that variable and you generate an output. And you're going to do the same steps, but based on the value that you input into that variable, then you're going to get different outputs. And boom, that's how you get a dynamic program, right? That's how you're able to, stream movies. That's how you're able to listen to music. That's how you're able to click on a button, right, and do a specific thing. That's why when you log into your Instagram, right, or Facebook, it knows your name, right, because it stores everybody's name as a variable, right? So it's doing the same things, following the same steps for everybody's profile, but it's able to customize it to you through variables. So there's probably a variable called username, right, that it uses to identify you. So let's see. So why do we need variables? Well, I use the word hard coding, right? So this is the opposite of using variables. So that's the practice of embedding fixed values or constant values directly into the source code instead of using variables. This makes your program inflexible and difficult to modify. So what would hard coding look like? Well, say we do have a program, right, where we have different users. Hard coding is when you just have it work for a single user in this example. So welcome to Java programming, Alice. You can't print this out for me, for William, or for another student, for Matthew or Michelle, right? This welcome to programming Alice is an example of hard coding because that value of Alice is never going to change. It's part of the string. Now, if we use a variable, we embed a variable in here. So welcome to Java programming, and then we embed the name variable. Then if you assign different values to that name variable programmatically, right, you get your code to make decisions and grab that name or assign that name through various different methods. Then you can make your program dynamic. So if you assign it Alice, of course it'll say Alice, but then here I can declare this variable, or I can assign it, I should say, a different value such as William, and then it'll say William instead. So variables, again, make your program flexible. It can handle different inputs. Now this might look like a hard-coded example, right? Because it just says Alice in this example. But once we get a few more tricks under our sleeve in the Java programming language, then we'll be able to make our program make decisions, handle user input, and then of course, be truly dynamic and handle different names. So how do you declare variables in Java? Well, it's a few different steps. First, you declare the data type. Then you define a name for the variable. Remember, these are the bare minimums. Optionally, you can initialize a variable with a string value, or sorry, with a starting value, not string value, right? It could be different values, not just string. So if you want to automatically give it the value at the beginning, you would call this initialization. You could also assign it a value later on. It is important that if you're going to use that variable, for example, if you're going to print it out, like in this example, you do have to initialize or assign it before you use the variable. Otherwise, this will trigger a compilation error. So always end your Java statements with a semicolon, of course. So that's step 4. Always, always, always. Doesn't matter what you're doing. Every statement needs a semicolon at the end. So declaring variables in Java. So let's look at the syntax. So again, step one, the data type. In this case, it's an integer, so I use int. I have to give it a name, so always name it something descriptive, something that makes sense. Well, for this variable, it's gonna hold a person's age, so I'm gonna name it age, naturally, right? And then I'm gonna set it equal to an integer value, which is 25. Notice, remember, syntax for integers, nothing fancy, just put the number as needed. You don't use commas, by the way, so if it's 25,000, you just put 25000, no commas in integers. But that'll trigger an error, so don't do that. So the variable age is initialized with the value 25. If you didn't initialize in the second example, they just do int age. So they declared it without assigning or initializing a value. Here, we assigned it a value of 25, so now age has been initialized now. So we call this assignment, and because it's the first time we're assigning it a value, it is considered technically also initialization. Now, if I do a third line where I do age is equal to 29, my current age, then that would be considered no longer initialization. That would now be assignment because I've now given it a value twice, a second time. So naming variables. So this is not necessarily syntax, so maybe I shouldn't have syntax on this header. Should maybe say convention instead, because there are several naming conventions, things you don't have to do, but things you certainly should do. So variable names must start with a letter, an underscore, or a dollar sign. There's different use cases where you might use underscore or dollar sign. We're not going to talk about that in our class. Maybe we'll talk about underscore, definitely not dollar signs. But in Java, yeah, usually we're going to go with a letter, but you could use these other symbols if you wanted to. The characters after the letter, that initial letter, underscore or dollar sign, again, we're really going to stick with letter for this class. You can have numbers, underscores, or dollar signs after the letter, or even more letters. There are no spaces allowed in your variable name, and they are case sensitive, meaning that age and age are different because of the capitalization here. This first age has lowercase a, this second age has uppercase a. So these are considered different variables. And this is already wrong, right? Because usually we go with camel case for variable names. So that the first letter of any variable name is in lowercase, and then all the other words inside the name are now uppercase. So we'll look at some examples, but in the example of camel case itself, right? Notice camel is lowercase, and then case is a new word, so we uppercase it. This is how we get around the no spaces rule. We just use casing so that it's easier to see the different words. So here's some tips for naming your variables in Java. Follow consistent naming conventions. So stick to, for example, the camel case. Don't mix, for example, snake case. That's another type of casing in programming. Snake case is for Python. So for Java, stick to camel case. Don't mix your casing right because it's going to make your code hard to follow. If you want to make your code easy to follow, stick with a single type of casing, camel case. For classes, that's called Pascal case. We'll cover that later on. So here's some other tips from naming your variables. Use descriptive and meaningful names. So early on, I thought you had to make your name short and really efficient because I thought it just looked, ugly or something to have a really long name. Once I became a professional software engineer, I learned, hey, it doesn't matter how long the name is, as long as it's descriptive. It is important to be concise where possible, but it's way more important to be descriptive and meaningful. So variable for the model year of a car should be, for example, model year. Naming it just year is not specific enough. Year can be used for any type of purpose, right? The year you were born, the current year, right? So model year is more descriptive for cars. For biography, a social media account, you could use the variable name account biography. So just naming it bio is not specific enough. Now consider what data types would these examples be. So model year, would that be an int? Would that be a char, a string, a boolean? Account biography, would that be an int, a char, a string, a boolean? Think about that. So I'm not going to let you know. I'm going to let you figure that out on your own. And of course, don't be afraid of longer variable names as long as they are descriptive. Descriptive, again, is more important than being succinct or being concise. Another tip is avoid ambiguous names. So kind of close to meaningful names. Avoid names that are too general, ambiguous, or use lesser known abbreviations. So for example, temperature in Celsius is more precise than temp, because temp could be Fahrenheit, could be Celsius, could be Kelvin. We don't know which system we're using here. So if you say temperature in Celsius, then it becomes immediately obvious um, what that integer value is representing, right? Because when you're writing out your integer, right, for temperature, you're not going to be able to put degrees Fahrenheit because you're working with numbers. You're probably going to be doing math with this temperature. We're going to be discussing, the kind of math we can do with the different data types, the kind of operations, I should say, you can do with the different data types, not always math, right? We're going to be doing that in some of the following lessons. But yeah, if you're going to be doing math with numbers, you're not going to be able to know if it's Fahrenheit, Kelvin, Celsius. So put that in the variable name. Yeah, be precise. Num users is an acceptable name because num is commonly used for a number. It's a common abbreviation or shortened version of numbers. So that's totally fine. Programmers use num all the time. It's just half as long. We like to save the trouble of writing out the full word. N users is not acceptable because N is ambiguous. N could be all sorts of things. So ambiguous names may confuse others and make your code harder to maintain. So if I go into your code and I'm, making changes to it or adding to it, if the variable names are super precise and descriptive, then I'm going to know exactly what that code is doing. Again, comments are one way to, describe your code, but if you get really good with your variable naming, you sometimes don't even need comments at all. That's how useful variable naming is.